All right, let's talk about a big idea. Today we're going to dive into something called the Interleaving Networks Theory. And it's a model that honestly challenges the most basic thing we think we know, what space even is. So get ready to kind of rethink reality from the ground up.
Okay, let's just sink our teeth into this, because this one sentence is the core of everything we're about to discuss. It's the central thesis, and it's going to be our guide as we unpack a completely new way to picture the universe. Everything flows from this.
So, the first thing we got to do is make a really radical shift in our thinking. See, for centuries, we've pictured space as this empty box, right? A continuous, smooth container, and we just put stuff like planets and people in it. This theory says, nope, that's all wrong. Space isn't the container, it's the thing itself. It's a fundamental grid, and matter isn't something you place in the grid. Matter is just a pattern, a ripple, an excitation of the grid.
Right, so, a new picture of space. What does that actually mean to say the universe is a 3D grid? Let's break down what this new foundation really looks like.
Okay, think about it like this. You're looking at a super high-res TV screen from across the room. It looks totally smooth, right? A continuous picture. But if you walk right up to it, and I mean get your nose right on the glass, you see it, the individual pixels. This theory is basically saying that reality itself is just like that. At our scale, it looks smooth and continuous, but if you could zoom all the way in, you'd see that space is pixelated.
And what's so cool about this is how it neatly solves this ancient problem in physics, the idea of action at a distance. How does gravity or light travel across a total vacuum? Well, in this model, there is no empty void. Influence doesn't have to make some magical leap across nothingness. It just travels from one node to its neighbor along these pre-existing connections. It's like a message being passed down a line.
So we've got this idea of a single grid making up our space, but that alone doesn't quite get us to the weirdness of the quantum world. So what if our network isn't the only one? This is where things get really mind-bending.
Now I want you to really let that sink in for a second. We're not talking about parallel universes in some far-off other dimension like in the comics. No, this theory says these other networks are right here, right now, threaded through the very fabric of our reality. It's like different colored threads woven into the same cloth. They're all there, together.
And you might be asking, how is that even possible? Well, because these networks are discrete, they're pixelated, you can just offset them. Imagine you have a 3D grid of points. Now bring in a second one, but shift it just a little bit so its nodes fall perfectly in the gaps of the first one. They structurally miss each other. It's kind of like laying two chain link fences on top of each other, but shifting one so the wires of the first go through the holes of the second. They occupy the same space, but they don't crash into each other.
Now, this is absolutely crucial. These separate realities aren't completely walled off from each other. The theory says there can be these rare bridges or couplings, specific points where the networks can touch and interact. And here's the kicker. What if the fundamental forces we experience, like electromagnetism, aren't fundamental at all? What if they're just the effect of these interactions bleeding through from one network into ours?
Let's move on, because this next part is maybe the most profound consequence of the whole idea. It's about where something like a fourth dimension could actually come from. When someone says fourth dimension, what do you picture? Probably some new direction, right? Like you have up-down, left-right, forward-back, and then something else that our brains just can't grasp. Well, what's so cool about this theory is that its answer is just no. It's not that at all. It's something completely different and way more intuitive.
So get this. The key takeaway here is pretty revolutionary. A higher dimension isn't a place you can go to. It's not a new axis. Instead, it's a relational property. It's a description that only emerges when you try to compare the geometry of one 3D network to another. It doesn't exist on its own. It only exists as a comparison. This paper analogy makes it so clear. Imagine two perfectly flat 2D sheets of paper. For any little 2D creature living on them, their world is just flat. Now, take one of those sheets and crumple it up. To describe the position of a point on the crumpled sheet relative to the flat one, you suddenly need a new piece of information, don't you? You need height. The third dimension just appeared, not as a new place, but as the only way to describe the relationship between the two 2D worlds. And in the exact same way, the fourth dimension could just be the language we need to describe how our 3D network is bent or curved relative to another one.
Okay, so we've built this amazing new way of looking at reality. What's the payoff? Well, this is where we can finally start applying it to some of the most famously bizarre ideas from quantum mechanics, and maybe, just maybe, make them feel less strange. So, superposition.
The idea that a particle can be in two states at once? How is that possible? Well, in this model, it's not in two places at once in our network. Instead, its state is simply distributed across multiple network layers at the same time. When we measure it, we're basically forcing an interaction with just one of those layers, so we see one result. It's like we're only ever seeing a slice of a much bigger, richer object that exists across all the layers.
And what about entanglement? Einstein called it spooky action at a distance. Two particles, light years apart, seem to be instantly connected. It feels impossible. But in this model, it's not spooky at all. The two particles only look separate to us in our 3D network. On a deeper, multi-layered level, they're not two things at all. They're two parts of a single, unified object. They're like two shadows cast by one object. If you move the object, both shadows move instantly, because they're part of the same thing.
Okay, this one is huge. For 100 years, the math of quantum mechanics has used imaginary numbers. And it's always felt like, well, a mathematical trick we had to use to make the equations work. But what if it's not a trick? This model suggests that the imaginary part of the math is actually describing something real and physical, the geometric offset, the phase shift between the different network layers. The math isn't a hack. It's a literal map of this deeper, multi-layered reality.
Now, you might think this is all just for the weird, tiny quantum world, but what if we scale it all the way up? Let's see how this idea of interleaving networks might give us some really elegant answers to the biggest puzzles in all of cosmology.
Take dark matter. We've spent decades hunting for some mysterious, invisible new kind of particle. But what if we've been looking for the wrong thing? What if dark matter is just normal matter? Protons and electrons, just like us. But it exists as a pattern in an adjacent network, not ours. It would still have mass, so it would warp the geometry between our networks, we'd feel its gravity, but our light, which is just a ripple in our network, could never touch it. It would be mass that we can't see.
And black holes. Physics tells us they're points of infinite density, a singularity, which basically means our math breaks down. But what if that's wrong too? A black hole could be a relational funnel, a place where the structure of our network gets so twisted and warped that it becomes intensely connected to the other layers. It's not just a point of no return in our universe, but maybe it's a gateway, a place where the different networks are fundamentally linked.
So, we've pulled space apart, rebuilt it as a grid, and then layered these grids into this incredible tapestry. What's the big picture? What's the one coherent intuition we can walk away with? This table just brings it all home, doesn't it? Look at how it reframes these huge abstract problems. The fourth dimension goes from being a mathematical abstraction to a real physical relationship between networks. Superposition stops being a particle in two places at once and becomes a single state spread across multiple networks. And dark matter isn't some exotic new particle, it's just regular matter next door. In every case, it takes something deeply weird and makes it feel tangible and structural. And that, really, is the powerful, provocative question this whole idea leaves us with. Is it possible that all the strangeness, all the paradoxes and puzzles of our universe, from the quantum to the cosmic, aren't signs that reality is broken or incomprehensible, but are maybe just clues? Clues that we're only seeing one layer of a much richer, deeper, and ultimately more elegant reality that's been right here the whole time.